Welcome at FEI TV. I'm your host, Kees Kersten, and I'm joined today with Karl Kersten, Senior Application Engineer. We're going to talk today about charging of samples. So, what about sample charging?
In general, using a traditional SEM, electron microscope, can cause charging effects on non-conductive samples. Charging means that the electrons coming from the beam hitting the surface of the sample, that the electrons cannot fade away properly, which will result in white spots in the image, and at the end, when you zoom in more, a white image completely.
Can all non-conductive samples be imaged?
That is depending on the application and the magnification. And it's best to show you with an example which we have here inside the Phenom. So we're looking at a magnification of 500 times onto a piece of paper, so it's plain paper. And if I start to zoom in more, so increase the magnification, there will be a certain point that the number of electrons is that high that they cannot fade away properly and result in a white screen. And about 5,000–6,000 times magnification, as we see now the white spots, which is charging.
Okay, I see what you mean. And what if we lower the vacuum even more, like some of our competitors do?
Lowering the vacuum will decrease the signal-noise ratio, and it also has a negative effect on the lifetime of the source. For Phenom, we chose to have the optimum for both. So we're still able to look at a lower vacuum, but we still want to produce high-quality images at maximum magnification.
I see that. Is it possible to reduce the charging effects anyhow?
Basically, you can have three ways in reducing this. First of all, you can increase the working distance between the sample and the lens. Mm-hmm. The second is to apply a silver paint or a carbon paint track between the sample and the surface of the holder. And the third is to use a sputter coat. To sputter coat your sample is applying a conductive layer on top of it, and that will eliminate basically most of the charging effects, so you can look at maximum magnification.
Okay, I see. So, in fact, do you advise to sputter coat all non-conductive samples?
It is depending on the application. We had a customer who visited us with a conductive paper sample, and with the Phenom we looked at a similar sample, but it wasn't coated, so it was a non-conductive sample. And the customer was really surprised and really happy because he could see the things he wanted to see at the specific magnification.
Interesting. Thank you very much, Karl, for this explanation, and thank you for joining FEI TV.